To clear any ambiguity, let's do an example. And this example is problem based, and the problem is taken from the real life situation. So at the bottom you can see there are 3 gears. They are mounted on the same shaft, and each of the gear has some defect. Maybe the teeth is broken, or maybe there's some casting defect such as blowholes, and because of these defects there are unbalanced masses. For example, gear 1, the unbalanced mass is of 200 gram. Gear 2, the unbalanced mass is 600 gram. Gear 3, the unbalanced mass is 100 gram. The radial distance from the unbalanced mass to the central, the axis of rotation is 5 centimeter. In case of gear 2, the radial distance from the unbalanced mass to the axis of rotation is 6 centimeter, and the radial distance between the unbalanced mass to the axis of rotation is 7 centimeter. Also, the axial distance between the gears are known. All are represented in the centimeters. Other very important information is the angular rotation. So angular position of each of the gear is known. If we take the gear 1 as the horizontal, then the unbalanced mass on gear 2 is at the angle of 45 degree with respect to horizontal, and the angular position of the mass 3, which is 100 gram, is at 90 degree angle with respect to horizontal axis. Next, what we'll be doing, we will choose 2 masses, the balancing masses, at 2 arbitrary planes. The first plane is A, the second plane is B. The radial position of balancing mass B1, which is at plane A, is known, which is 4 centimeter, and also the axial distance from the gear 1 is known, which is 10 centimeter. Similarly, at plane B, the second balancing mass B2 is placed, which is unknown. However, the radial distance from the axis of rotation, which is 3 centimeter, and known, and also the axial distance from the other gears are also known. The only unknown here are the balancing mass B1 and balancing mass B2. So how to deal with the problem? So we can formulate a table where we can present the plane 1, plane A, plane 2, plane B, plane 3, mass, the known 200, B1, the balancing mass B1 is unknown, the balancing mass at gear 2 is known, which is 100 gram, balancing mass at plane B is unknown, and the last gear 3, the unbalanced mass is 100 gram. The radial distance of each of the balanced or unbalanced masses are 5, 4, 6, 3 and 7 centimeter. The axial distance are -10, 0, 10, 20 and 30. Why there is 0? A very critical information was shared in the lecture that we can choose, in case of movement, we can choose a arbitrary plane around which we have to take a couple or moment. So in this case we have taken an arbitrary plane at plane A, and all the movements of other gears is taken around A. Interestingly, if there is a couple or movement of plane A, plane 2, 3 and this plane B, the direction will be, for example, if there's a movement of this unbalanced mass at gear 1, it will be, for example, clockwise. Then the movement of couple of remaining masses will be counterclockwise, because they are on the other side of this arbitrary plane. I will repeat again. If you take the couple or moment of this gear, this unbalanced mass at gear 1, which is 200 gram. If this is a clockwise direction, then the movement or couple produced by the other balanced or unbalanced masses will be counterclockwise direction. That's why I use -10 with the axial length, so that at the final, when we calculate the movement, it will be negative. So negative represents clockwise direction and the positive represents counterclockwise direction. Or you can say that this arbitrary plane where we are taking the movements from left hand side, whatever it is, it will be taken a minus, just as this, -10, and the right hand side are taken as the positive sign. Because we are taking the movement around this arbitrary plane A, then we are counting this axial distance 0, because there will be no movement, and by this we are getting rid of this balancing mass B1, not physically but in calculation. Similarly, distance 10 is the distance from this arbitrary plane from this gear, the unbalanced mass as gear 2. Then 20 centimeter is the distance from the arbitrary plane to the balanced mass B2, and the last one is 30 centimeter distance is the unbalanced mass of 100 gram at gear 3 with respect to arbitrary plane. Force can be calculated by multiplying mass with the radius. So we calculate 200 into 5 is 1000, B1 into 4 is B1 into 4, 100 into 6 is 600, B2 into 3 is B2 into 3, 100 into 7 is 700. Couple can be produced or can be calculated by multiplying force into axial distance. Here's the force, here's the axial distance, 1000 multiplied by -10, 10,000, and with the minus sign. B1 into 4 multiplied by 0 is B1 into 4 multiplied by 0. So this couple will be equal to 0. Then 600 multiplied by